Hi guys, welcome to part 4 of org mode refactoring. We have been a bit all over the place in this series of videos. We couldn't really spend as much time on live coding as we wanted to because we just couldn't get our head around all the work that we had to do. And also we had lots of problems with recordings and so on. So we did most of the work offline really. So you're joining us now where pretty much basic support for reading org models has been implemented. We have an org mode codec for the input. We've converted all the library models into org. We converted all the reference models into org. Few cleanup tasks were done as well. So where we are at present is we can start using the org mode models as our canonical source of modeling data. We haven't done that so far. What we've done so far is we kept the dia model still here, and we just put the org mode model side by side as we've done with the JSON in the past. Of course, we can't really do that for too long because, well, the whole point of this was that we would model in org mode, and then we would generate, well, basically move completely to org mode, so dia will become out of sync at some point. I guess the purpose of this video will be mainly to move completely, to untether ourselves from dia for the first time in many years. So in some ways it's a bit of a sad moment, I guess. We've been using dia for quite a long time, but we have more or less reached the limitations of what we can do with dia. So I suspect this is really the right time to do it. We're still, our org models are not perfect by any means. I mean, there's still a few niggles with it. But to be fair, it's already a big improvement on what we had, particularly because we will be able to edit templates in a much seamless sort of manner. So for example, if I take types and I look at any of these templates here, as you can see, these guys are now here and it's very easy to edit them. If you want to, you can even go as far as stitch moding them, do whatever it is doing, and then exit the template. Now we still have a slight problem here because every time we enter stitch mode, we can't exit the template so easily. We need to figure out how one does not lose the key bindings for org. So at the moment what we're doing is we're closing that by hand, and then we have to somehow return to the org file. In fact, I'm not even entirely sure we did it before. Which is yes. Not entirely clear how we've done this before. I mean, as I said, there's still some sort of teething issues with this. Just need to figure out exactly. Okay, Control C, Control K works. So presumably Control C, Control C probably still works. No. Okay, so yeah, the problem at the moment seems to be that if you go into org mode and then change the mode of that buffer, then the key binding. Oh, okay, that seems to work. Okay, it's not very clear really what's going on there, but to be honest, it's not a big problem because at some point we'll figure out what's going on and solve that problem. What's more important is that now at this point in time we can do all of our work from here. So for example, if I make a change to this template and then if I ask Dogen to regenerate, if I just have a quick look, we haven't started clocking, but as you can see here, very easily we've updated the template, which is exactly where we've been trying to get to all this time. So that's really good. That's exactly where we wanted. We've also, well, as you can imagine, with org mode now we can do whatever we like. We can copy paste. You know, it's just an Emacs buffer, so this will make life much easier. I mean, there's still a few things like org rom and so on that we looked into, but we haven't quite got ourselves to work properly. So let's just start this story. We haven't quite got all those bits and pieces to work properly, but then to be honest, it's not likely we're going to get everything working on the first attempt. So the key thing now is to try to gain some practical experience of working with org mode and see what kind of problems we face. We're also very visual, so it's going to be interesting to move to a slightly more textual sort of implementation. As you can imagine, in this textual world, you now have to kind of keep, well, if you compare that to the graphs that we are used to, where you can see all these things in a nice kind of fashion, that's actually not possible at present. What we will do at some point in the future is we are going to implement a codec for PlantUML, and what that will enable us to do is we will enable us to at least get some kind of UML diagram out of a model, so we can still keep a visualization. But however, I don't really want to get too hung up on this right now, because we have a lot of actual work to get on with. Best not to get distracted. We already have some kind of PlantUML story in the backlog, so we will just take it from there, to be honest. Okay, so what we're going to do now in this video then is just a couple of tidy ups, really. We're going to, well, we still have a lot of work related to this org mod model. We've achieved one side of it, which is to generate code from an org model, but we need to do the other side of it, which is at present, if you look at the org model transforms, so these transforms are bidirectional, I guess. So there's a model to org and there's the org to model, and model to org is not yet implemented. Well, it is implemented, to be fair, but it is implemented in a textual form. So what we're doing at the moment is we're literally handcrafting the models, just to make sure, well, just to get the right format, which is fine. It was the initial approach. It's fine. There's nothing wrong with that. But what we really, really want is to create a transform inside of our org model, which is this guy here, and we would like to have like a document to string transform, and we'd like to just generate one of these models and then pass it to that transform, and then we'll just output the corresponding org mod file. And that is the beginnings of a round-trip system that we'd like to implement. We're not really going to spend too much time on this right now, but the idea will be that in the future we'd be able to read the org mod document, do some kind of additional processing, and inject some stuff into the org mod document, and then output it again. That's something we'd like to do for the future. So let's try to, after all of that, let's try to get ourselves with our head back into what we're trying to do here. And let's see. So I don't think we can start deleting the diet documents just yet, because we need to generate the org mod models and make sure that they work. So we'll do that afterwards. So what we'll do is we'll just reorder our story slightly. So let's just leave that as it was, and let's start this guy instead. And the idea being that we would like to test the existing workflow that converts dia models over to org models. Make sure that that still works and generates exactly the same code. After that we can delete the dia models. So this transform will have two steps effectively. The first one will be take a codec model and convert that codec model over to a dia model. But interestingly enough, I thought that we were already in codec space here. In fact, I think we are. Yeah, we are. It's just that we're just basically using all this manual iteration. I wonder if it would make more sense to create a second transform for this, or perhaps just have parallel functions. Let's think about this for a second. Yeah, to have a parallel transform might be easier. I wonder. It's only about 3 or 4 methods in here, really, to be honest. So, and I think we're probably going to have sort of for each method, we're going to end up with an equivalent method for the new transform, really. Except they're not going to behave quite the same way, but and then we need to move some of this outputting code to the output function. Annoys me slightly to have to create another transform, really. Yeah, I'm gonna be lazy and just create an area here for new methods, and then we'll just have to sort of deal with new world and old world. I don't really like calling the new methods new. I prefer calling the old ones old, because at the end we can just remove them. But for now, that will do. So let's just create a new method here. Right, so the objective of this is just literally to generate an org model. So we will continue with the vast majority of this code. Tracing, right, so the difference is the artifact part will not be handled just yet. So, well, to be honest, we could probably start with an artifact and then just, in fact, to be honest, we probably need a couple of things, actually, to be honest. Just as I did that, I just realized we need like 90% of the stuff from there. Right. Okay, cool. Now the first thing we need to do then is to say, well, we need some kind of top level method, just like this toString method here, which takes a model and starts to construct the org mod model. So instead of a toString, what we really need is static. Now we probably need to include something we haven't included yet, which is Dogen.org types entities document, perhaps. And so if we could just say org entities document, and we could just call this to document. And right, so that's simple enough. So the objective of the toDocument will just be to worry about the top level transform of the document. See if we can fit it all in one line. Right, here we are. So, and then what do we do? Well, we can just simply say return a document. And in here, the first thing you could say is convert the codec model into an org mod document. And then you could just say const out to doc to document m. And then I'm not sure if we could say string to no org to string. So we want the document to string transform. I don't think yet. This has not been implemented yet, so we can't really call this transform. Just leave it there for a second. Although, to be fair, nothing stops us from very quickly creating the interface with this guy. A few things here are not needed, so we don't need an iStream. Chat pointer, fine. String, fine. So let's just take all of these guys, and let's just say that this guy converts an org model document into a string. And in here, what we really want is something very similar to this. But instead of returning the document, we like to consume the document. So, right, so something like this, right? This is a very simple interface. And what we can then do is we can just come to the implementation and say, just return us some random string. As long as the interface, oh. I think we've done something wrong here. So apply, blah blah blah, and I put to apply somehow. So we have the tracer, we have the doc, we open up, and then as we did with this one. Now this guy here is a bit more complicated, so we relied on the helper. I'm hoping we don't need to do that for this second transform. Should really have snippets for all this stuff, but sadly we never seem to have the time. A lot of copying and pasting here, it's not really necessary. Right, so what are we doing then? We're saying that we will receive an org mode document. This is the document string. From ID, we're still not quite naming these things properly, but let's go with that. Say doc, and then here let's just call this to string R, and then we just return the string, and that's very, very simple. And what we can also do while we're here, grab the include, find our transform, and in this guy here, I like to keep the includes in some kind of weird order. So one thing that we didn't really do very well is that we call these things transforms, when in reality they're more like chains, really, because they are calling other transforms. At some point you need to review that. There you are. So now do const auto s and document. Okay, I think org is not happy, so org trans. Apply. Now, if we could, no, I think transforms. Convert the document, the org document into a string. So that's going to basically be something as simple as getting the tracer and the doc. Okay, and then finally r.contents, excuse me. Should probably close the window. Nothing worse than sneezes. Never know when they're coming. Right, okay, so this looks extraordinarily simple. Finally, construct the artifact contents. Okay. So this is the start of the steps we expect for this new world transform. Very, very straightforward. Now let's look at what the first bits are. So we seem to be doing title options. We'll start with title. So first thing probably would be that we need some kind of section, presumably. In fact, these are affiliated keywords. So if you have affiliated keywords, how does an affiliated keyword work? Right, so we need a key and a value. So I think what we should probably just do is something like org.entities.affiliated keywords, factor type, title, and for this one we can just call it title. And to be honest, we probably could just do everything in one go, but it doesn't really matter. Right, there we are. So what do we do here? We get a title, a key, title.value, and then of course we push back the title. So that handles the first case. And then we could have something very similar. I mean, we're not doing this the most beautiful code ever. The objective here is just to get us going. So let's call these options. And the options are this string here. As you can see, this is almost like a transliteration of what we've done before. And this is by design. We really are not trying to be very clever here. Next, we need to handle the special case of tagged values. Now for this, what we'll do is we will just do another method here. So two property drawers, presumably. And this guy here will return, just like we return a document here, we can just return a property. Oh, it's because we call it a drawer, just. Okay, and that's just going to basically create a property drawer. Now we don't really need a stream. Or spaces, if I'm honest. Just a set of tag values. Perhaps we should start documenting these methods so that we remember what they do. Convert codec set of tags values into an org mode property drawer. Righty, so now then, don't expect too much complication with this guy, so we just need to create a drawer, return it, and then if we look at the tagged values chap, so if the tagged values are empty, we just return an empty drawer. Although to be fair, we probably don't want to be creating empty drawers, right? Because we don't want to create empty drawers because we don't really want documents with empty drawers. So what we really want to do is to say create a drawer if there is one. So let's just use optional. So if there isn't one, we will just return nothing, and then it's the caller's job to handle that. We don't never please entirely as to how these things get implemented, really. It seems to me it would be nicer if we just didn't have to worry about this use case, but then the caller would have to do some other stuff, and it's not really clear what the optimal solution is, so we always end up with a solution that just gets us going. We'll just comment these guys out for a second, and then so what we'll do then is we'll say, well, well, of course there is the other option, which might be the most sensible one, which is to basically say, if there are no tagged values, don't even bother. Yes, actually I'm gonna take back what I just said. I'm gonna assume that we will always create a property drawer, because at the end of the day you still have to check for the optional at the other end anyway. So we'll just basically assume these guys are not empty, and then what we'll do is we'll do something like if so if TV, if not TV.empty, then we will do something like drawers.pushback, and then what we're going to push back is going to be two property drawers TVS. Okay, that makes perfect sense. So now then, if we could just say here, for each tag value, we would like to create whatever it is that we put inside of a drawer. For starters, we always know that the properties of the drawer is going to be sorry, so the type of the drawer is always going to be a property drawer, and then in here, if we just have something like a drawer content, perhaps dc, and then dc.key. Right, so in here we're not going to do anything particularly special. We're just going to take the key and the value, copy them across, and then finally we just need to push interesting. I thought the drawers would have a list of contents, so okay, I think we can just push back DC. Okay. Now, of course, we probably could do something even simpler. We could just create the thing in one go, draw content in one go, and then push that back. Let's see what happens if we do that. So if I just say something like using drawer contents, and then if we just say pushback drawer contents dot tv dot tag. Sometimes it's just a question of readability, really. I do like less code, but I also like code that I can understand. So if it's just too much information compressed, so you see, when you look at this code, it's just too many moving parts to it. It just makes me confused. Whilst I do like one-liners, I think this is easy to read. I might change my mind in the future, but for now, I always tend to do the first pass, the easiest one, and then we worry about it later. Right, so here you go. So that was very simple. We just generated a new drawer. Now, what we do next? So if there is documentation, we just stream the documentation. Now this is going to be a text block without any parsing. So So if there is some documentation, we can just simply create a text block, perhaps, yep. Let's call this a text block, and then tv.type, something like a block type. So we'll call this a text block, and perhaps tv.contents. And then if we could just say section blocks pushback tv. Okay, so that should hopefully give us the top level of the document. And I think we handled pretty much everything here except for elements. Now elements, of course, are always a bit of a nightmare, so we will need this mapping as well. Just mapping the children and the parents. Then we need to then say, please walk parent to child. However, the walk parent to child is going to be slightly different now. So the way we're going to walk parent to child is going to be, first we don't need the stream. So create an arc document from a codec model. So there's just a bit of noise in the background. Okay, so so we don't need a stream, and it's quite a lot of noise. I'm just going to put this on pause for a second. Okay, seems like the noise is quieting down a little bit. Try again. Seems like work next door. I have to pause it again. We need to figure out how this recursion is working then. So the idea would be that the parent to child walkabout that we need to do well, it has to return as a set of headlines, I guess. There's not a lot of options. So let's just call this listed list. I'm sure that we would have used a list. Document has a list of headlines, so if we just return org entities headline, something like that. Not quite sure exactly how this is going to work, but that kind of gist. And then in here we would like to say please return the headline, and here we will just basically create the map, the list, and return it. Okay, and then clearly we need to say something like r dot headlines, whatever that thing is. Now we know there is no s, so we just need to supply something like a level. Okay. And now let's have a look at how the walk parent to child code works. It's going to be very similar, if I'm honest. So find the ID. It's interesting that we don't throw here, but it's fine. I wonder what we use as the ID as well. Clearly this is not going to work if we try to map org to org. This only works org to dia because containing element ID is only populated in dia, I believe. So there's a bit of a bug here. Let's see if we have that story already. We have a similar problem with org nodes models. Containment properties are not populated, so round stripping of org to org will not work. Okay, but that's fine because it's not a problem we're dealing with right now, so we'll worry about that later. So, what are we saying then? We're saying basically, we assume that there is some kind of containment property that we can rely on. That enables us to create a parent to child map. Now, it's not ideal that we don't throw here if this doesn't succeed. So we should probably do something like if I so if I is equal to the end, this is not good. There's an exception. So child not found, I guess. Something like this. Again, it doesn't have to be exactly perfect, but just sufficient to get us going. We tend to always do these exceptions and all this validation because at some point something is going to break, and it's good to just have some kind of idea why. And even if it's not brilliant, at least it gives you some indication as to why everything is broken. So we could just put some very simple comment here. And now that we know for sure it does exist, right, so now then, so the idea of this is that we're walking parent to child map in reverse. So every time we get an element, we figure out if the element is contained by somebody. If it is, we then go and make sure that we find its parent. However, it's interesting we're doing it this way because presumably this means we can have a fairly random order. So let's just have a bit of a look here. How exactly do we get this ID in the first place? So if the ID is empty, right, this is actually maybe working by luck more than anything else. So we're basically saying here that we walk in parent to child, we supply a stream, the level is 1, but then we supply an empty ID. That's just a const string, so it's not going to find anything in that map. Or perhaps it will. And what it will find is all the elements that have got no containment. Right, okay, I get it. Okay, so, and then we will just loop through those, and for each of them we create the elements. And if those have an ID, in other words, if they contain an ID, yeah, so it's in reverse. Okay, fine. So let's just try to understand then how we're going to map this to the new world. So we will find, we still want to throw if there is no correspondence, but what's more important is we want to convert to an element and then, yeah, okay, so I think this is it really. I think we're there now. We just then need to say all of these guys here need to now generate the right thing. So we probably just want to say something like this. Right, let's just put a minimal comment here. Box up the codec model from parent to children cursively and generates arc nodes headlines for each. Right. Okay, so that's what this guy does. And now what we really want is, instead of a insert, we want the 2 elements. And what this will do is it's going to say, well, to be honest, it's probably not 2 element as such, whatever that thing is, to headline, I guess. So our job will be to convert a headline into an element. So let's have a look at what that entails. So it'll be something like this. So we're not going to need a stream for starters. We will need a level, to be fair, and we need an element. So that looks about right. And as we do this, now let's have a quick look at what we do for the element. So we could just start by creating the headline, and then we can say, where we are recording. Yeah, we are 44 minutes. So now let's just think about it for a second. We just have to slowly iterate through these things. So tags, what are tags? Okay, just a list of tags. So we can simply say the level, the title perhaps. Is that a name or a title? Title is the name of the element. So you can see we're just slowly constructing the headline, and then we can have some set of tags, and here we could just very nonchalantly push back the tag, and this is going to be something like a tag, and to be honest, perhaps we could just take this thing here. However, we do have to be slightly careful here because the tag probably contains more than what we need. So perhaps we could just say something like element tag new. You can see now why I don't really like creating the new ones as new, because now we're going to have to go through all of them and fix them instead of just being able to delete the legacy ones. Okay, so there we are. So what we do is we create a tag, determine what the fallback type is, and then we just say, well, you're either a module or you're an element. And to be fair, I mean, sometimes we become a bit lazy with these things, but I wonder if we should not just have a static entities tag to tag and just give it the elements. Seems simple enough. I mean, just determining the right level of function is part of the task, really. Sometimes you just go a bit too crazy and create too many functions. Sometimes you don't go crazy enough, but it's difficult to find the middle ground. So let's say something like this: if return something like this. Not exactly perfect, but slightly more readable, perhaps. Some of it is also just opinion, but I mean, I think it does look a little bit better to say something like this than all of that stuff. Okay, so that guy is going to go away, create a tag. So at this point in time we have more or less all of the headline: a level, a title, and a tag. Now we need to well, we need to worry about the tagged values, but we've already done a lot for tagged values. So what do we have here? Okay, so we can create a property drawer. Right, so this is where we need to be a little bit clever, because in the past the property drawer was created in one place, whereas what we're saying at the moment is we need to create the property drawer and then pump loads of stuff into it. We might even end up with a property drawer that's empty if there's nothing of these kinds. So we probably should take a slightly different approach here. Let's have a quick look at what we did before for the property drawer. We said we assumed that there would be some TVs, so that's fine. Right, so I'm just going to say let's create a new method instead. Let's just say add. Sorry, noise is returning, I'm afraid. So let's just do something slightly different. Let's basically say add to property drawer. This may not be the cleverest thing in the world, but what this will allow us to do is to have lots of different methods that add to the property drawer. This is just going to be one of them. So now we already have a drawer. Somebody has already created this for us, and all we're going to be doing is to be adding these chaps to it. And then in here we'll do something slightly different. We'll basically say create a drawer, give it a type, add stuff to the drawer, and push it. Right, so this is a slightly different approach, and it would make sense if the only place we were using was here, but since we are doing lots of other stuff to the property drawer, now all of these guys, parents, element attributes, these are going to be added to the property drawer. So if we just go up to here, perhaps create a few of these. Just gonna go for overloading here. Don't necessarily need to, but right, so we're just gonna add different kinds of things to the drawer with the presumption that the drawer already has been set up. So that seems sensible enough. As long as there isn't two of these guys with exactly the same signature, which I suspect there won't be. Might not be the best and cleanest, but kind of get us where we're trying to get to. I'm a big believer in sort of first empirical approach, I guess, because I think a lot of times you come up with some very clever design and very complicated, it does all sorts of things, but in the end, if you don't really try it and see what happens, it's hard to decide what's the best approach to do something. So I prefer to just give it a go at something, and even if it's not particularly brilliant, and then once you see the implemented code and you look at all the problems it has, because there will be quite a few, then you can just do a quick refactor, and then you can do a refactor with specific purposes as well, because you know why it's breaking and you know why it's not working. So I think open-ended refactors where we have no idea why something is not working, just doing the initial design and at the same time trying to find the perfect way of doing something. Right, we will need some kind of where are we here? Okay, so what are we doing here then? We're basically saying probably need some kind of stream for this. So std stream os. Now the title. So the property drawer is going to be populated very, very simply with a key and a value. Key, just that lovely string. The value is slightly more complicated, so let's compute the value. There'll be no spaces. We just need to say pump all the stereotype stuff into here. Let's not worry about end lines either. And then let's just say that the value is going to be whatever's in the stream. Okay, and then finally we can just basically say add the contents. Yeah, so as you can imagine, when we defined this original approach for org modes, we just used a string and we did it really simple. Of course I knew that was not a brilliant thing to do. And of course you could say, well, if you knew you're gonna at some point have to do all this clever stuff and create a model and so on, why didn't you do that? And yet the reason why is because I would like to first have an idea. Okay, something's happening downstairs. Typical chaotic day here. One thing we probably should be careful with is we don't really want to be adding things unless we need to. We did a slight mistake here. We should have double checked that stuff coming in is not empty. So stereotypes. So if the stereotypes are empty, then don't bother. If the parents are empty, then don't bother. And then here we want the same sort of logic. Yeah, so as I was saying, I think I was saying, it may seem very obvious that we needed some kind of proper model, etc. And we should have just started immediately by creating a proper org mode model instead of creating a string-based representation, which we knew was not going to be sufficient, and so on. However, our approach is a bit like we try to always do the simplest thing first, and then we try to see what the problems are with the simplest thing, and then we evolve it from there, because that gives us a baseline as well. For example, now we know what the shape of the org documents are, and we know that there's processing and we know it's round tripping. So it's much easier now to we've done parents. Oh, I think we've done them all. No, but there's one more element attributes, this guy here. And yeah, there is a lot of hackery involved and so on, but it's all to do with the empirical process, I think. We do expect a lot of experimentation, a lot of things that are not quite perfect. For example, you could see here, originally this was just one big hack. Now the hack is slightly less hacky, because we are now processing keys and values more accurately. And at some point we will have a slightly better way to convert these things. And this is kind of how Dogen evolves, really, from one experimental approach to the next. Right, we just have to be very careful that we don't do a mistake here, because this is where we could introduce things that could cost us a lot of time, like a copy and paste error, for example. I mean, the other thing you can quite clearly see here, and now you can see clearly how our thinking goes, right? First, there's a lot of copying and pasting here. At some point you get bored of copying and pasting, and you're going to be like, well, actually, 90% of this code is all common, isn't it? We're just creating a drawer content. So why can I not just have a two-drawer content that takes a key and a value? And could be slightly above here. So we could just have a very simple entities our content, and here we could just basically say, well, just give me a constant string by reference key and a constant string by reference value. I mean, we still are using the old style. Everything is const by reference. I'm sure people will tell me that's not the best thing to do, but we'll have to look at that at some point in the whole project. So what was that? It was just next to tag. So if we could just take one of these guys here and then say, well, something like values. Let's see if it's a short-lived one, so we don't have to pause. Well, as you can see here, the drawer content is very, very simple. Now, although this seems a little bit weird that we're going backwards and forwards, but now, let's have a quick look at the drawers that we created. Tag values. Right, here's a drawer. So now perhaps, quite easily, we could say something like this. Now you could say, well, why didn't you start by doing that in the first place? But like I say, it's weird. My brain seems to prefer seeing the examples. Where are we doing here? My brain seems to prefer seeing the concrete examples and then making this refactoring after the concrete examples, even though sometimes it's really obvious, and you know, because we're programming for quite a long time, you can see it. But and also, like I say, I get very confused with very long lines, so I like lines that are more or less self-contained, even though it results in more code. But you see, here we created our contents, and here we push it back. Okay, that seems simple enough. And now that we have this approach, we could perhaps have a new look at these guys here and say, well, can we not do exactly the same thing? Now, of course, these keys are very large. So it's not going to quite be as readable, but sadly, not much of an option here. As you can see, whilst it sounded all great, in practice the net result is not actually as beautiful as one would like. Perhaps what we can do, not a complete solution, but let's just have some constants with these guys here. And this could just be primitive underlier, because I mean, these are fairly, oops, max sometimes, a bit too powerful for its own good. So let's try this instead. And so that's kind of how the refactoring process goes around here. We just try something, we see how it looks. Sometimes it looks very ugly. We don't like it, and then we iterate a couple of times. And at some point we figure out, actually that's not too bad. Let's go with that. Max is liking green for that, but you are. Okay, so basically rinse and repeat. We just need these for a few of these guys. Probably should have created a macro for this by now, but we'll go with what we've got. And it, you know, of course, many of these things you can't do this in the real world, because of course, if you're working in a team and you, people don't want you to be refactoring forever and so on. So perhaps you end up not being able to do the exact same approach as we do here. I certainly don't do this at work, but type. key bindings today. Max not happy for some reason. Right, what are we trying to do here? Constant string. Oh, we just must have deleted something here by mistake. Okay, we've done something very wrong. Let's have a quick look at what that invalid actually supposed to be. The thing with Emacs, I think, is that relies a lot on muscle memory, and every so often my muscles seem to be a bit tired. And then it take a while to actually, part of it may be also to do with recording, because I think you're not in the zone. It's difficult to be in the zone when you're recording, which basically means that you make a lot more mistakes, including key bindings, and then you have to spend some time trying to understand what you're doing. Right, so let's have a look at this guy. Not quite sure this is still moaning. Max is still unhappy about this. I'll have to look at it at the end. And so as you can see, this approach is a bit long-winded, and you may even say counterproductive at times. But the other advantage of this approach, which is also an important factor, is that if you end up with lots and lots of work and small bits of work here and there, which we tend to, and you never quite know when you're going to get the next bit of work. The simplest approach that it requires less thinking tends to be the best approach. Now I just want to know why Emacs is so upset about this guy. Don't really see anything particularly wrong with it, but it is convinced there's something wrong with it. Right, so what we'll do is we'll just get this thing to compile now, because okay, there's also the fact that we are okay, maybe this is also explaining why. Okay, so yeah, so as we explained, we don't really want to output the flags if they're not true, and away you go. Okay, so this is simple enough, this code. I think Emacs has gotten a little bit confused here, so let's just try to refresh this buffer. Okay, that's good. It was just Emacs getting confused. I must say LSP mode is very good, but occasionally it just needs a bit of a kick. Not very often, to be honest, but right, so now then, we should be able to convert the headline. And the idea here will be that we should go back to where we were in the document, have a quick look at how we created a drawer, and do something very similar. So, as we are creating the headline using an element, right, so now just have to be slightly careful here. What we're trying to say is right, this has worked also by luck, I should think, because really what we're doing is we're checking to see what's empty and what's not empty, and then determining what to do. We're going to take a slightly different approach now. We're going to basically say something like this: create the drawer, set it to properties, and then add a whole load of stuff to the properties. So we already have tagged values. So then we should just say add. Interesting. What happened to our tagged values? Right, let's just get them from. But to be honest, we even need to create a variable. Sometimes I think we're over compulsive on this, so let's call this e.tagged values perhaps. And now we just have to keep the exact same order. Add to property drawer. Now, so all we need to do very simply is this: copy what we got here, comma D for the drawer. Skip the order, and it would. However, we need a slight trick, which is if the drawer is empty at the end, well, don't bother adding it. Right, something like this, right? Stereotypes done, element out of its space, okay. And then we can just do something really, really simple, which is if the dot contents are empty, and if we're not empty, then add a drawer. Otherwise, just throw it away, and then that should give us what we want. Now we don't really care about spaces, and we don't really care about tagged values, which were named incorrectly anyway. So where are we then? We have the headline, the drawer. We add a whole lot of things to the property drawer. If the contents are empty, then we don't bother processing it further. And then we just need, well, just need to handle the documentation. What do we do for the model? Yeah, you can see the copying and pasting is starting to show a pattern. So the documentation is not empty. Create a block, it's a text block. Create a section, push back the section, goes into the R, and there we go. Documentation is done. Okay, so that's kind of all looking fairly straightforward. And then finally, the only method we're missing, I should think, is what we should now document these guys a little bit better. Converts different kinds of codec elements into the contents of a property drawer. Drawer is already set up externally, so that we know for sure. Okay, the noise is starting again. Let's put a pause for a second. Afraid it'll be stop and start a little bit today. Are we recording? We are. Okay. So now then, create contents. Create a KVP contents for a drawer based on supply inputs. Something like this. I mean, sometimes these comments are really not very helpful at all, but we try our best because when you look at these codes in a while, it's good to have some kind of indication what we're doing. Creates a tag for the element type. Right, now then, finally, creates an arg or the headline representing element. Okay. So we just need to be able to say same thing as this, but for an attribute, presumably. Right, so now let's just organize things a little bit better, because this is a big confusion now. So, new methods, right? So the first thing we have in our new methods is to draw a content, which is fine, followed by all of those to add to property drawer. Which also look fine, followed by to tag, okay, and now we have the two headline of the attribute and the element. So we'll just replace this guy with attributes. Oh, actually, I think one thing we did not do is did not rename the attributes to a slightly more conventional attribute name. Righty, now then. We could say to attribute, to headline, should I say? And this will be presumably r dot push, no, r dot headlines, I guess. Push back to headline, and then we will need some kind of way of knowing the level, to be fair. We do have that, and then the attribute should be the parameter being pushed back. Okay, that actually looks vaguely sensible. And then presumably just return the headline. Right. Okay, so that's kind of all making a little bit of sense. This is going to create some headlines. Now, of course, you have to remember these things should recurse. So see if the noise remains at a decent low level. Okay, so now we will parent to child, the level goes up, we supply the ID and the map. So now look through all the elements at this level and recurse to their children. Right, so this is what this method is trying to do. Okay, so this is not like the most amazing bit of code, but should do the trick. And now finally, we just need one last copy and paste job, I think. The attribute code. So we'll just start by copying and pasting everything. Now, we probably could right, I think we could probably steal some of the implementation of the element for this. So we will need something like, well, let's just copy the whole lot, I think, if I'm honest. Right, so we're going to need the level. Attribute.name, that's good. Then we need the attribute tag. And presumably that will already be doing the job. Now this won't do the job because of course toTag only takes into account elements, not attributes. To be fair, part of me would like this to be create a tag for the element or attribute. One thing I've noticed as well is that as LSP becomes a little bit more functional, it's a little bit slow to respond. I'm not sure whether to pause the video now or not. Let's hope the noise will go away. As I was saying, LSP becomes slightly slow to respond, more functionality gets able to do, and that is actually making life a little bit harder for programming, because those slight delays make you a little bit, well, your typing gets a bit worse, I think, because of those slight delays, at least my typing is. We just need to grab the attribute tag. Of course, part of me then says, why bother with all of that, given that we don't even supply the attribute? And that is a fair point. That is a fair point, actually. So you can see here the typical thought process around here. It starts off very generically, and then soon enough we realize actually the generic approach just adds a whole load of infrastructure for no reason, and we don't really like to have a lot of stuff for no reason. So sometimes we revert and just do things simply. So let's see what happens here then. So tags.pushback, or this is tag of attribute tag new, presumably. Right, so then we create a drawer. Now of course we don't really have all these things in the drawer, so let's give it the parents, stereotypes, and the element is the attribute itself. If there are no contents, then don't worry about it. And then now let's just get rid of a few of these things. So right, so we now need to handle a couple of cases here, and these will be handled exactly the same way as these guys here. So if we just do something like this, so if the attribute name type is not empty, then we can create something like this, and we could push back that to the drawer. That actually looks perfectly sensible. And then if you could do something almost identical to that, perhaps we forgot to open brackets here. Okay, one thing we've done that's not right. See, this is a typical copy and paste error. See, we just destroyed the value. Not meaning to, but so focused on the copy and paste that we did not really look into what we're doing. resulted in a very annoying error. Of course, the good thing about this is it all comes out in the diff, so you can clearly see it in the diff. Right, cool. So now then, where are we then? We have the values coming through, we have some kind of contents, and then we handle documentation. And I think that is it for attributes. Oh, actually not quite. The documentation will be very, very different. So first let's just get rid of all of this stuff. So the way documentation works is we need to determine certain properties of the documentation. This is a bit of a hack, of course, as so many things are around here. So what do we do then? We're looking for certain specific markers on the attribute, and that then allows us to create a block. So, so in here we want to create a greater block, presumably. This is going to be a problem because I don't think we support types of greater blocks. But because all of them are source at the moment, I think this will be okay. So I think we just need something like a parameter. And if I just create a parameter here. Call this just P, and the parameter is effectively just telling us what the type of the block is. Again, this is not really what you'd say the most polished approach. And I think we could just get away with, at the very end, just add the documentation, so I think that will work. So in effect, all we need to worry about is the parameter handling here. So in all these cases, we're going to be creating a greater block. To be honest, I'm not even sure why we did this for licenses. We probably don't need to, but don't need to make a fundamental thing there. And then finally, if nothing matches, then it's just a simple plain text block. Right, okay then, so bit of hackery, as you can imagine. Very nice coming from downstairs as well. So create text block to the section, and away you go. And then finally we just return R, and that is it. Okay, we're already an hour and a half into it. So, well, first let's just see if this compiles. So this is just the first stab at it, of course. We always do this. We always go for a first stab. The first stab we just expect things to kind of like more or less hang together. It's not expected to do anything. I mean, there's no test, there's nothing. All this will do is compile and do something once we enable it. Okay, it compiles. Okay, some noise coming from downstairs. Can you imagine it's a bit challenging to code something complicated with so much stuff going on? But that is more or less our daily life. Right, so this now does something. Whether it's the right thing or not, we don't know yet. But that's sufficient for a commit. So the things, this is also another important point around here. So you see, we didn't really spend a huge amount of time here doing loads and loads of tests, trying to understand what's right, what's wrong. I mean, if you're working on a more professional environment, you probably would create lots of test cases, and for each test case, double check to see if the conversion is correct and so on. But if we did that, we would end up with a lot and lots of tests. So we tend to use tests sparingly. We have to maintain the test, so of course that's you know, work. So what we do instead is we look for overall tests that give us that sort of confidence. So what we're going to do is we're going to plug in the outputting to string transform, and then we can diff the outputs of the existing org mod models versus the new ones, and that will then tell us where we went wrong, and we'll keep going until those tests don't break. So that means I don't have to write another set of tests now, because the existing tests are sufficient. And once that's done, we can remove all the old methods. And that's kind of the typical approach we take around here, just to try to limit the scope of the tasks. Okay, since we already are an hour and a half into it, and since there's been so many interruptions, what we're going to do now is we'll just do a bit of a offline work now. We'll just stop for a second, and then we will resume later once we finish with the string transform. Thanks for watching.